Rational numbers. Before solving the exercise, let us revisit the concept that we have learned in this chapter. Mainly, we have studied two properties in this exercise, namely commutativity, and second one is distributivity. The word commutative comes from the English word means moving from one place to another. So you can see here, children are commuting from one place to another. Likewise, we do in mathematics when we solve rational numbers. That is, there comes many times when we have to move the rational number from one place to another in order to ease our calculation. Another property is distributivity. For an instance, you have this box consisting of 12 partitions. That is 1, 2, 3, 4, 5, 6. 6 into 2 equals to 12 boxes. So there are total 12 boxes. The same can be represented using 4 into 2, that is 8 boxes. That is 1, 2, 3, 4 into 2, that is 8 boxes, plus 2 into 2, 4. That is, these both figures represent the same number of boxes. The only difference is we have distributed it. That is, 6 into 2 can be written as 4 into 2 plus 2 into 2. So basically, we have studied two properties in this exercise of rational numbers for class 8th chapter 1. To make you understand it more better, we have an example. We have this problem, 2 over 5 into minus 3 over 7, minus 1 over 14, minus 3 over 7 into 3 over 5. There are many ways to solve it. The one is to just go with the flow. That is, first you solve this, then subtract this, then subtract the final two terms. The another way is to group them or to move them. Grouping them will be termed as distributivity, and moving them from one place to another is called commutativity. If we see here, 2 over 5 is getting multiplied with minus 3 over 7. Also, we have minus 3 over 7 which is getting multiplied with 3 over 5. So if we shift this complete portion, that is minus 3 over 7 into 3 over 5 to this side, that will be called as commutativity. And with this, the value of this whole expression will not change. So we wrote 2 over 5 into minus 3 over 7 as it is, minus we shifted this thing, that is minus 3 over 7 into 3 over 5 to this place, and the remaining is minus 1 over 14. This we were able to do by the principle of commutativity. So this complete as it is, and we just change it in order to ease our problem, and this as it is. Now the another property, that is distributivity. Over addition we are going to use it. That is, we see minus 3 over 7 as common here and here. So we took it as common, minus 3 over 7, and whatever is left we will write in the bracket. That is, here we are left with 2 over 5, and here we are left with 3 over 5, and minus 1 over 14 as it is. This we were able to do with the help of distributivity. That is, this whole expression is equal to this expression. That is, we just concatenated it. Now we solved within the bracket, that is 3 plus 2, 5, 5 cancelled out. So we are left with 1, and this as it is, and this as it is. Again, by taking LCM, 14, 7 2s are 14, 3 2s are 6 of negative, and 14 1s are 14, 1 into 1 is 1, obviously of negative. So when we solve it, we get minus 1 over 2. So this was just an example to make you understand about commutativity and distributivity. With this, let's solve our exercise. Question 1. Using appropriate properties, find. So we have two expressions. We'll have to simplify them by using the properties. So first of all, we will see how we can proceed to solving these expressions without any properties. So that will be a longer version of doing it. So we'll first multiply it, 3 to the 6 and minus 1. So it will be obviously equal to 6 of negative over 15. Then we have positive of 5 over 2. Then we will solve it, minus 3 upon 5 6 30. So do we have any cancellation opportunity over here? Well, yes, we can do that. 1 3 is a 3, 3 1 is a 3, 0. Now here also 3 2 is 6, 3 5 is 15. So what we are left with equal to sign minus 2 over 5 plus 5 over 2 minus 1 upon 10. Now we can take LCM, that is 10, 5 2 is 10, 2 2 is 4, that will be minus 4 plus, because we have plus here, 2 5 is 10, 5 5 is 25, and obviously 10 ones are 10 and 1 ones are 1. Here, like terms, minus 5 plus 25 as it is, this whole is divided with 10. That again gives you minus 5 plus 25. We'll subtract and sign will come off greater number. So 25 minus 5 is 20 over 10, 0 0 cancel, and you get 2. So this was the longest form of doing it, that is, we did not use any properties. We are told to do it using appropriate properties, which we have studied in this chapter of rational numbers. So we will do using these appropriate properties. So you don't have to do this by using this long form of expression solving. Now we will use appropriate properties. So how we do it? First of all, we will see whether we have any common numbers. These are rational numbers because they can be written in the form of P over Q, where Q is not equal to 0, that is, denominator is not equal to 0. So first of all, we will observe any common numbers in the given expression. So we can see we have 3 over 5 here and also 3 over 5 here. Here 3 over 5 is getting multiplied with negative of 2 over 3. Here it is getting multiplied with 1 over 6. And this rational number, that is 5 by 2, that is positive 5 by 2, a different number. So we can bring this whole complete part to here, that is called commuting, or we can use commutative property of rational numbers, that is, the whole expression do not change its value when we commute. So we can do this like this. This whole expression is equal to this as it is, that is negative 2 over 3 multiplied with 3 over 5. Now this whole expression, do not commute 3 over 5 into 1 over 6. You have to commute this whole with minus sign, because commuting, when you move from one place to another, you also take your head, that is, you move with your complete body. So 3 over 5 is incomplete because it contains negative sign. So we will commute it, that is minus 3 over 5 into 1 over 6, and this is left, so we will write it as positive of 5 over 2. So we haven't changed any values so far. Now we can take 3 over 5 common from both these, that is from here and from here. 3 over 5 is common, so we are taking it, and this is called as associativity. When we take 3 over 5 from here, it is, so what we are left with, so we are left with minus 2 over 3. So we write minus 2 over 3, and here 3 over 5 has been written. What is left is negative of 1 over 6. So we can see, so we can write minus 1 over 6. Also, you can check whether your step is correct by multiplying it here. So it gives you negative 2 over 3, and it is getting multiplied with 3 over 5. Same here, and here minus 1 over 6 getting multiplied with 3 over 5. Again minus, because when we will multiply it, it will eventually come out to be minus 3 over 30. So here again minus 3 over 6 5 is 30. Now what we are left with is positive of 5 over 2. Now you can write it here because while in learning phase it is a good practice to write here. This is by commutative property. Double M U Tative property of rational numbers, and this we are able to do because by associativity. Associativity property of rational number. And this property says that the value of the expression do not change its value, because if it changes its value then there is no use of using such properties. Now further solving it. First of all, we solve whatever is in the bracket. So here 6 will be the LCM. You know very well how LCM comes. Let's make you understand how the 6 came. This is how you do LCM. In the rough space you can do it. You write 3 and 6 denominators of both the terms. First of all, with the least number 2 doesn't go. 2, 3 is 6. Now we're left with 3 only, so 3, 1 and 1, and you multiply these. 3 to the 6, therefore it came. Now 3 to the 6, you multiply denominator with the LCM, 3 to the 6. Now 2 as divisor, 2 to the with numerator, 2 to the 4, that is negative of 4 because negative sign is here. Now again minus 6 1 is 6 and 1 into 1 is 1, and 5 by 2 as it is, that is this term, 3 over 5, and further solving it, minus 4 minus 1 is minus 5 and 6 in the denominator, plus 5 over 2 as it is. Because this is multiplication, bracket means multiplication, we can reduce the terms, that is 1 5 is a 5, again 1 5 is a 5, and 1 3 is a 3, 2 3 is a 6. So here minus 1 into 1, it is 1 obviously, minus 1 into 1 is minus 1, denominator 2 into 1, here it is 1, so 2, and plus 5 over 2 as it is. So due to space issues we are writing it here, you have to write it downwards only. So again denominators are same, so we can straight away write denominator as 2 and you can perform the operation here. Minus 1 and plus 5 gives you plus 4, because ultimately they are getting subtracted and sign comes off greater number. So 4 over 2, reduce it 2. So using the properties we also get the same answer. The only thing is that we solve a question quite easily and in less number of steps. So that is your first. Now the second part, here we will observe whether we have 2 by 5 somewhere. Yes, here. The 2 by 5 is getting multiplied with 1 over 14. Here it is getting multiplied with minus 3 over 7. So we will make these pairs and this will remain separated. So we are writing it here. This whole equals to 2 over 5 multiplied with minus 3 over 7, obviously in brackets. Then we are commuting this thing complete. So it is plus 1 over 14 because it is getting multiplied, therefore we have to take it. That is, we have to take both these terms into 2 over 5. Easily we are left with this thing, that is negative of 1 over 6 is getting multiplied with 3 over 2. So we have written the same expression, we just commuted it. So you can write using commutative property. Commutative property of rational numbers. This you can write. Now let's take common. That is 2 over 5 is common in these two expressions. That is this one and this one. So we will take 2 over 5 as common due to associative property. And we take bracket. Whatever is left here we will write. That is negative of 3 over 7 is left here. So we will write. And the sign here is positive. So we are using associative over addition. So plus, now 2 over 5, we are left with 1 over 14. And here we are left with this expression, that is this one. We can solve it or we can reduce it here itself. So 1 3 is a 3 and 2 3 is a 6. So when you solve it, in numerator you get minus 1 because 1 into 1 is 1, and denominator 2 into 2 is 4. Now let's solve the brackets. So we will do it in next step, writing 2 over 5 as it is. This again in bracket. 14 is LCM. We are not going to show you how we do it. It's simple. Just use the previous steps. That is the steps used in question number 1. 7 2 is a 14, 2 3 is a 6. Obviously with negative sign because negative is there, and plus 14 1 is a 14, 1 into 1 is 1. First of all, you divide denominator with your LCM, and whatever the divisor comes, you multiply it with the numerator. Minus 1 over 4 as it is. Solve it. Equal to 2 over 5 bracket as it is, or you can eliminate now because it is the last step. 14 as it is. Again, different signs, subtract, sign comes of greater number. So 6 minus 1 is 5, and sign of negative here, minus 1 over 4 as it is. Solve it. You can cancel it. There, it is 1 after cancellation. So 2 1s are 2, obviously minus sign, so 2 into minus 1 is minus 2 over 14 into 1 is 14 minus 1 over 4. Cancelling opportunity. 2 1s are 2, 7 2s are 14. Now due to space issues, we're writing it here. You have to just continue it downwards. So it is negative of 1 over 7 minus 1 over 4. Again, LCM, we cannot do it straight away because denominator are same. LCM will be 7 4s are 28. 7 4, 4 into 1 is minus 4, minus 4 7, 7 into 1 is 7. Now, same sign, we add them up. So minus 11 over 28 is a required answer. We cannot reduce it further. So in this way, you solve your question using properties. If we would not have used any property, the amount of time taken would be more, and sometimes question become cumbersome to solve. And that completes your question number first. Question second. Write the additive inverse of each of the following. So we have studied in this chapter of rational numbers that what is an additive inverse, or the opposite of a number. So we have studied that additive inverse is nothing but a number which when added to a number makes the sum as 0. So we will take first one, that is 2 over 8. What should be added to it so that we could make this number as 0? So we can add negative of this number, that is minus 2 over 8. So this whole expression will be equal to 2 over 8 plus minus is minus, when you open bracket, 2 over 8. Again, same number with opposite sign. Here it is plus, where nothing is written, it means plus. We can cancel it. This gives you 0. So what was the number that we have added? The number was negative of 2 over 8. So this is the additive inverse. That is negative 2 over 8 is your additive inverse of the first one. Likewise, the second one, or the second part, it is negative of 5 over 9. So what should be added to it? This number becomes 0. This rational number becomes 0. So it is simple, 5 over 9. Because when we cancel it, it gives you back as 0. So what was the number? So this was the number. That is your additive inverse, or the opposite of a number. Here we have 5 over 9. So that was the second. Now the third one, negative of 6 over negative of 5. So before moving any further, let's solve it. Negative negative can be cancelled out. We are left with 6 over 5. So the number is, we have 6 over 5. What should be added to it so that we can get this number as 0? So it will be negative of 6 over 5. Because when you open it, it gives you 6 over 5 plus minus is minus 6 over 5. This is of obviously positive, nothing is written. It means plus of 6 over 5, negative of 6 over 5. They get cancelled out and you are left with 0. So here the additive inverse is minus 6 over 5. So your answer is minus 6 over 5. So that is your third. Fourth part, here we have 2 over 9. So you have studied in your previous classes and previous standard that this minus can hover from denominator to numerator without changing its value. Also, this negative sign can be written here as well. So this whole number is negative of 2 over 9. So what should be added to it to make this number as 0? Here it is negative, so we will take its positive, 2 over 9. This will give you 0. So if you now cancel it, negative of a number, this rational number, positive of this rational number gives you 0. So we have its additive inverse as 2 over 9. That's your fourth. Now the last part, 19 over minus 6. So as we have stated earlier, this negative can hover to this position without changing its value. So we can write negative of 19 over 6. Here we will explain another easy method in order to get additive inverse if you get confused. So we will add something to it. Let's take it as x. So the answer should come as 0, because by definition of additive inverse means the number that should be added to a number so that it ultimately gives you 0. Let's denote it as left hand side and this as right hand side. This you know from your previous classes. Let's keep x here. So there we have 0, so you can write 0. When you move this term towards right hand side, the sign gets converted. So negative becomes plus, so we'll write plus 19 over 6. So actually 0 has no value, so x equals 19 over 6, and this is your required additive inverse. And that is your last part of question number 2. So if you get ever confused in solving additive inverse, just follow this approach. That is, what should be added to the given number so that it equates to 0, and then solve for x. That's your second. Question third, verify that negative of any negative number gives you a positive of that number. And we'll have to take x in first case as 11 over 15, and in second case x equals to minus 13 over 17. So it is very similar to the previous one. So how we can do it? Let's do for the first part. So we are given the equation as negative of negative x equals to x. Now we will plug the values of x, that is equal to negative of negative, this as it is. What is the value of x? In place of x we will write 11 over 15 equals to, again we'll have to verify it, that is left hand side must become equal to right hand side. Here x, again x, that is here 11 over 15. Now we will solve it. Minus minus is positive. 11 over 15 equals to 11 over 15. So it is verified here because your left hand side is equal to right hand side. That was your first. And now the second one, x equals to minus 13 over 17. Now again we will write the given equation, that is minus x equal to x. We will plug the values. In this case x is negative of 13 over 17. Minus as it is, minus as it is. Now the value of x. Again we are introducing one bracket so that we don't get puzzled. The value of x is negative of 13 over 17. So negative of 13 over 17. This bracket closing. Now this bracket closing. What is the value of x? It should come equal to minus 13 over 17. Now we'll have to prove left hand side whether it equates to right hand side. This minus as it is, the bigger bracket like this. Now we are solving this thing. Negative negative is plus, so positive of 13 over 17. That should equate to minus 13 over 17. When you open it, it simply means minus 13 over 13 equal to minus 13 over 17. Again it is verified. So what we infer from this equation, if we take negative of an inverse of a number, that gives you the number itself. We have verified in both these parts. That is your third. Question fourth, find the multiplicative inverse of the following. So we have 6 parts. We have to find multiplicative inverse. So we have studied in this exercise that another name of multiplicative inverse is reciprocal. So reciprocal is simply a number. When we multiply it with a given number, the answer, or when we solve it, should equate to 1. So in first part we have negative of 13. What should we multiply to it so that we get 1? So let's take it as x, we don't know. So answer should come as 1, not 0, because 0 is in case of additive inverse. We are finding multiplicative inverse or reciprocal. We have left hand side and right hand side. Here it is getting multiplied. We will take x here and shift this negative 13 towards right hand side. Doing so, this multiplication becomes division. So 1 over minus 13. Remember the head, you have to take complete body. So that is your multiplicative inverse. Minus 1 over 13 or 1 over negative 13 is the same thing. Plug it here. So negative 13 into 1 over negative 13. 13 will get cancelled out. Negative negative will get cancelled out. You will be remaining with 1. So that is your multiplicative inverse, or the answer is 1 over negative 13. Negative of 13 over 19. We have negative of 13 over 19. We don't know yet. We'll take x. This should give us 1. So x remaining on left hand side, taking this on right hand side. So 1 we have here, division sign, minus 13 over 19. So this is x equals to 1 over negative 13. This goes upwards and obviously it is getting multiplied here. 19. So reciprocal or the multiplicative inverse in this case is 19 over negative 13. So the answer is 19 over negative 13. So if you have observed, you don't have to always use this form. What we do in multiplicative inverse or reciprocal, the word reciprocal means reversed. Here it was numerator over 1 understood, denominator is understood, it is 1. We are just flipping it. There is 1 over 13 and also with the sign part. Here again we flipped, that is 13 goes to denominator, denominator 19 goes to numerator with the sign part. So we will not solve like this. This was just for your explanation. So what we will do, we will flip it. That is denominator 5 will become numerator and numerator 1 will become denominator. That is your multiplicative inverse. Because again, if you take it 1 over 5 into 5 over 1, it should give you 1. Yes, it does give, because it gets cancelled out and you are left with 1. Fourth part, first of all we will solve it. We cannot cancel because we cannot see any cancellation opportunity. So first we will equate it. Negative negative becomes obviously positive, minus minus is positive. When we multiply it, 5 3s are 15 and 8 7s are 56. Now we are in position to find its reciprocal or multiplicative inverse. Simply flip it. That is 56 over 15. That is your required reciprocal. Now here, first we will solve it. Minus 5 into minus 2. That gives you 2. Because minus minus is plus, 2 into 1 is 2 over 5. Now flip it. 5 over 2 is your required reciprocal. Last part, negative 1. Negative 1 over 1. This is its elaborative form. Now we will flip it. 1 in numerator over negative 1. Or further, we can write it as minus 1. Why? Because this minus can hover to 3 positions. That is, this whole number, that is this complete number, in this case rational number, can be written in 3 ways. Number first way is already written, that is 1 over minus 1. Another way is minus 1 over 1. The last way is minus 1 over 1. These all 3 represents the same number, that is negative 1. So in this case, negative 1 is the reciprocal of negative 1, not the positive 1. So that is your fourth. Question 5. Name the property under multiplication used in each of the following. So here is the test of your understanding on properties that you have learned in this exercise of rational numbers. The first is minus 4 over 5. It is getting multiplied with 1. And what is happening? This equates to 1 into minus 4 over 5. The given number is negative 4 over 5 and it is getting multiplied with 1. What would be your answer? That is minus 4 over 5. The same has been written here, minus 4 over 5. Now here, 1 is getting multiplied with that number, that is 1 is getting multiplied with the given number, in this case negative 4 over 5. When you solve it, you get minus 4 over 5, which is again the same. So what it is representing? It is representing multiplicative identity. Multiplicative identity. That is, whenever a rational number is getting multiplied with 1, its value does not change. So as you can see, when the number is getting multiplied with 1, it remains the same number, negative 4 over 5, as it was initially. When 1 is getting multiplied with negative 4 over 5, we are left with minus 4 over 5, the same number. Now the second part, what is happening here? First, a number is written, negative 30 over 17, it is getting multiplied with minus 2 over 7. Now observe on right hand side. Now they are taking this second number, writing it as first number, and writing first number and making it second number on right hand side. So they are commuting, that is moving from one place to another. Also this equals means that the value of this expression is similar to this expression. So this property under multiplication, because in each case we are multiplying, represents commutativity. The third one, what is happening? We just studied in previous question. Here we have negative of 1929, and when we observe here, they are flipping it. That is, minus 19 is becoming denominator. Denominator 29 is becoming numerator. So very well, it is reciprocal, or the other name was multiplicative inverse. That is, what number should be multiplied so that we get number as 1. So that was your fifth. Question 6. Multiply 6 over 13 by the reciprocal of minus 7 over 16. So bear in mind, it is not saying that multiply 6 over 13 with minus 7 over 16. It is saying reciprocal of this number. So first of all, we will take as 6 over 13 as it is. We are going to multiply it with what? Its reciprocal. So let's find it reciprocal. It's simple. Flip it. That is, 16 will become numerator and minus 7 become denominator. That is a reciprocal of this number. We cannot reduce it, so we will equate it. 6 6 are 36, 3 over here, 6 1 is 6 plus 3 is 9. 96 over 7 3 is 21, 2 here, 7 1 is 7 plus 2, 9. Obviously minus into plus 1 gives you minus. So the answer is, we will take it here, 96 over 91. This is not wrong. We're just writing it in another way. So that's your required answer for question number 6. Question 7. Tell what property allows you to compute 1 over 3 into this thing, as they're writing this as it is. Now they're multiplying it with 6 first, then multiplying 4 over 3. So what they've done, we have 3 separate numbers. This is one number, another number, third number. So first they are multiplying second and third number, and in second case they are multiplying first and second number. So we have studied in this chapter that rational numbers follow associativity. That is, they do not change value when associativity property is used. So what happens in associativity? Suppose you have 3 numbers, A, B and C, obviously separated with commas because they are different numbers. So if we multiply first A into B into C, that is, we are first multiplying second and third number. This equals, that is, this doesn't change value. If we write it like this, first we multiply A into B and then we multiply C. So the same is happening here. So the name of the property is associativity. To generalize it over multiplication, because they are multiplying eventually. That is 7th. 8th is 8 over 9, the multiplicative inverse of negative of 1 and 1 by 8. Why or why not? So first we will have to write this number in simplest form. So we have 2 numbers. One is 8 over 9 and the another number is minus 1 over 8. So how we solve it? It is a mixed fraction. To solve it, we simply write, obviously the sign will come. First we multiply it, 8 into 1, then we add it to numerator. So 8 plus 1 is 9 and denominator comes as it is. The question says, is this number, that is 8 over 9, is it a multiplicative inverse of this number that we have solved? That is negative of 9 over 8. What this question actually means that first of all we will have to find this number's inverse and we will have to match it with this number. So what will be the multiplicative inverse of this number? It is simply flip it. That is 8 over 9. This negative has no real value. Finding multiplicative inverse because it will come as it is, because this can take 3 positions. We have stated many number of times before as well. Clearly this number is not equal to. This is how you represent not equal to. First equal to, then it crossing it. 8 over 9. Therefore 8 over 9 is not a multiplicative inverse of minus 9 over 8. The another reason can be given as, if it satisfies this equation, that is 8 over 9, when we multiply it with minus 9 over 8, it should give you 1. Is it giving? Well, we can cut it. Well, they're not same because here we have minus 1. Obviously, this was 1 because we reduced it. That is equal to 1. Well, it is not equal to 1. Therefore, this number, that is 8 over 9, is not multiplicative of this mixed number, or in our case, minus 9 over 8. That is 8th. Ninth question of exercise 1.1 is 0.3, the multiplicative inverse of this mixed fraction. Reason, why or why now? So first number is 0.3. Another number is this one. We will solve it. 3 3s and 9 plus 1 is 10 over 3. So when we multiply it, they should give us 1. So 0.3 actually means 3 over 10. We write the number at the denominator, 1 at place of decimal, followed with the number of digits. Here only 1, so we will write 1 0. When we multiply it with 10 over 3, it should give us 1 in order to make this number multiplicative inverse of this number. That is, we have solved 10 over 3. So yes, in this case, it is easily visible. 3 gets cancelled with 3, 10 with 10. So 1 equates to 1. So it is true that 0.3 is multiplicative inverse of 10 over 3 or 3 and 1 over 3 when written in mixed fractions. This is just to make you confused. First of all, reduce it to simple fraction and move forward. That is 9th. Question 10th, write a rational number that does not have a reciprocal. We have studied in this exercise 1.1, chapter name rational number. Take any rational number, a over b. It will always have its reciprocal as b over a, but with an exception, and that exception is 0. Why? Because 0, obviously if nothing is written below, it means 1. When we try to find its reciprocal, it will be 1 over 0, but it doesn't make it rational number now, because the definition of rational number says number should be written in the form of p by q, where denominator should not be equal to 0. In this case, it is undefined or infinity. It is no more a rational number. So 0 is the exception. Second, a rational number that are equal to its reciprocal. Obviously, we just did in one of the previous questions. First one was -1, because when we found its reciprocal, it is understood it is 1 in the denominator. Flip it, 1 over -1, and this 1 can hover in 3 positions. We have already told you in previous questions. That is, again, it gives you -1. So one number is, we found out, as -1. Another number is obviously 1 itself, because nothing denominator means 1. Find its reciprocal, it will be, flip it, 1 over 1, and this also can be written as 1. So we have two numbers, -1 and 1. Third, the rational number that is equal to its negative. Well, it's very well known, it is 0, because it's negative. What is negative 0? It is again 0, because on a number line, that's a number line, it is separated in negative and positive side. Take any rational number, it has its negative rational number, but 0 is a number which is equal to its negative. So 0 is the answer. That's your 10th. Question 11, fill in the blanks. First, 0 has dash reciprocal. We studied in previous question, 0 has no reciprocal. Second, the numbers dash and dash are their own reciprocals. Again, in previous question, 1 and -1, whenever we reciprocate them, we get the same number. Third, reciprocal of -5 is what? So we have -5 upon 1, flip it, 1 over -5, minus 1 over 5. Fourth, reciprocal of 1 over x, where x is not equal to 0, while it is a rational number, would be, we will flip it, it will be x over 1, or x. Fifth, the product of two rational numbers is always a rational number. For an instance, we take two numbers, 5 over 2 into 3 over 2. That gives you 15 over 4. It fulfills condition of our rational number, that is, it can be written in the form of p over q, where denominator is not equal to 0 So it is the product of two rational numbers is always a rational number. The reciprocal of a positive rational number is positive. As you can see here, we have 5 over 2 for an instance. We'll find it reciprocal. That is, flip it, 2 over 5, it is again positive. It will follow for any rational number. So that completes your last question for exercise 1.1, class 8th,